All right, so my name is Felipe Gasper. I'm with cPanel/Plesk, and I'm going to talk about Unicode and Perl. It's always kind of it's an oddly contentious topic given Perl's reputation as a text processing tool, something so fundamental to computing nowadays. It's really something, it's surprisingly confusing to a lot of even very, very good Perl developers. And maybe there are things I'm confused about, but hopefully I can shed some light, and if there's something I need to be deconfused on, please hit me up. So the magisterial talk on this topic that a lot of people have actually mentioned to me about that they saw was from Rick Signes back in 2016. You can't, I don't know if you can see it there, it's almost an hour and a half long, and he really goes into gory details about all sorts of cool stuff. Just amazing, some of the stuff that Perl can do. I'm not going to go into that much detail, but I am going to reflect on a lot of the time I've spent talking to people, mentoring people with the issues that they encounter. Hopefully we can avoid them, and hopefully we can look at Perl and see how we can maybe make the environment and even the language itself a little less prone to some of these gotchas that can bite when you least expect them. As we do this, I'd like you to keep three profiles in mind, three different perspectives on this problem. The first one probably applies to all of us. You're a Perl user. You're writing Perl code. You're doing it the right way. You're not doing anything funny. You just want to write some Perl and it's going to work, right? Second one is you're a Perl API user. Probably that means you're writing an XS module. Maybe you're embedding Perl in something. It's fun, but it's a little gnarly, so you're staying up late at night, which is, you know, we've all been there, right? And then the third person is the Perl Maintainer. There are very, very few of these people. I thought Jedi Master was the appropriate image. These people are less the intended audience of this topic. I might actually be about to upset any of them if they're in the room, but I think that's okay. So first, we have to talk about what's in a Perl string. Even such a simple question can be a topic of some uncertainty. Obviously, it contains a sequence of unsigned integers conceptually. It's, you know, ASCII A is what, 60, and ASCII B is 61, yada, yada. And then it contains nothing else. So if you've ever heard something, is it bytes, is it UTF-8, you know, flags, and this, I think this has an encoding? No, that's all inside Perl. Don't worry about it. Don't think about it unless you have to, and hold that thought. Again, a little weird. So yeah, sequence of unsigned integers, but in the context of a string, we usually like to use this phrase code points. They're interchangeable as far as the actual meaning, but code points is the specific thing in the context of a string. Of course, code point is itself kind of an esoteric concept, so we like to say the word character. Now, if there are other Unicode geeks like me in the room, you know code point and character are two different things. You can have multiple code points that make up a character, so it's a little fudgy of a thing. But for the purposes of this talk, let's just all agree, simplify on the notion that a code point is a character, even though we know they're not. That divergence in the models is not really germane to this talk. So for our purposes, a string in Perl is a sequence of characters, nothing else. We don't have to worry about anything else. Now, some of you out there who are XS wizards are saying, aha, I am an XS programmer and I wield magical C superpowers. I need to know about the details of what Perl is storing inside that string. I think you don't. Occasionally, yes. I have actually in the forum seen a case of late where I kind of had to back out some of the earlier versions of this slide. Like, yeah, okay, that person needs to know. Generally speaking, though, your modules will be better if you do not try to think about how Perl stores the string. So on to our first area of confusion, really categorical confusion, Unicode versus UTF-8. We kind of use these terms interchangeably, but but it's weird that we do that. Maybe we get them confused because they start with the same letter. But they're actually like completely different. They're almost inverse things to each other. A Unicode character is the abstract thing, is the glyph, the symbol, the squiggly, the emoji, whatever you want it to be. UTF-8 is the bytes we use to record those down. So if you have ASCII lowercase a, that's hex 60. E with an accent is 2 bytes. Curly double quote is 3 bytes. And that little thing down there, I forget its name, it's back to 2. If you want to think of it like this, you think of an analogy, Unicode is to UTF-8 the way a data structure is to JSON. If you have a Unicode character that you need to store on disk, you store it as UTF-8. If you have a data structure that you need to store on disk, you store it as JSON, or CBOR, or serial, or message pack, whatever have you. So right away, we know some nonsensical phrases. If you see these, then you know there's confusion in the air, potentially. And if that may actually be a problem in somebody's model, maybe even in your own, so you know if you hear bytes of Unicode or UTF-8 character, neither of those concepts exist. These are both nonsensical. Another one that's actually a topic of confusion, like right now on the Perl 5 Porters mailing list, is the terms decode and encode. To illustrate the difference, if you have JSON, when you encode a data structure, you start off with a data structure and you end up with bytes. When you decode, you take a blob of bytes and you end up with a data structure. We all know this. JSON's probably kind of common parlance to all of us. UTF-8 is the exact same situation. If I start off with characters and I want bytes, I encode to go characters to a blob. Blob, bytes, I kind of fudge the difference in the two in the slides. Decode, of course, is the inverse operation. I start off with some bytes and I come up with characters. The problem here, if you're maybe thinking as a Perl programmer, what's a byte? Because we just defined a string as a sequence of characters. There are no bytes in play. How do we solve this problem? Well, if you wrote JavaScript in the 90s or the early 2000s, you know what we do, we just pretend. We pretend that a string that contains characters 0 to 255, we just pretend that those are bytes. And it works remarkably well. So, looked at from Perl's perspective, we're not actually encoding per se, and this is where our Jedi Masters who maintain the Perl core, they get a little dicey with this word decode and encode, because to Perl, you're not actually encoding or decoding anything, you're just converting one set of code points to another set of code points. Perl doesn't know or care about encode or decode. And likewise, the decode goes the other. The decode is the inverse operation, but again, to Perl, it's all characters. It's all just code points in a string. There's nothing that intrinsically differentiates the encoded from the encoded from the decoded form. Which means you have to maintain your own bespoke type system in your Perl code. You either do what cPanel does, and everything is a byte string, and if you have a character string, just put it in this one special place, and then you decode it at the end, because we assume all strings are bytes. Or if you need more of the Unicode goodness, then you probably have to standardize on character strings and be very, very careful to decode and encode at the proper points. Or else you're going to get what we've probably all seen at some point using Perl code. You see a double encode. You've messed something up, or your colleague messed something up, and now you've got a double encode. You've got what is called mojibaki, and you get sort of weird squiggly characters rather than the nice, French or Russian word you were hoping to get. You can get a double decode, but it's a little harder. It's a lot less likely. Double encode is usually the problem. For the 536 devel cycle, there was a lot of discussion on P5P. Should the UTF-8 pragma, which the Modulicious library enables it by default, should this be in the Perl feature bundle. When you use v5.36, should this enable UTF-8? It sure looks like it should be, right? UTF-8 is modern. We want modern Perl, so let's everything use UTF-8, right? What could go wrong? Well, think about what this does. Don't say the answer, just look at it and think about what you think that's going to do. Of course, your use UTF-8 code will print out Latin 1, code point 255, right? WTF. The reason why, of course, is that use UTF-8 has caused Perl to decode our 2 bytes of the Y with the diaeresis, so now we have 1 character that happens to be character 255. So when you print that, it's printing byte 255, which happens to be Latin 1. That problem doesn't happen if you don't use UTF-8. Counterintuitively enough, right? We know why this happens. A lot of you probably didn't need me to explain that, but to a newcomer to the language, and we all want there to be more Perl users, right? This is a real WTF moment. I'm going back to Python. Now think of this. What is this output? Well, it's quite simple. It outputs UTF-8. Why wouldn't it output UTF-8? I used UTF-8, right? But it outputs UTF-8 for a very different reason. Capital A with the line above it happens to be code point 256. 256 doesn't fit within a byte, and so when Perl outputs code point 256, it has to encode it as something. And what's it going to encode to? Well, UTF-8, it might as well. So it's going to print that, but it also warned us with this kind of odd-looking warning, wide character in print, and so it gave me UTF-8. So depending on what I've actually printed under the UTF-8 pragma, I might get Latin 1, I might get UTF-8. More confusion, right? More WTF moments. Now, to understand why this happens, and to look at it more, we're going to go into how Perl does its input and its output. Generally speaking, I'm assuming most of us use Perl in a Unixy environment. In a Unixy environment, the entire environment is bytes. There are no, on Linux file systems, all paths are pure bytes. This is actually, I'll get back to this later, this is one of Perl's problems on Windows. But in a Linuxian or BSD, whatever environment, the environment is bytes, and the Perl strings, again, are characters. So somehow, when Perl takes input, we have to convert the bytes from the environment to characters in Perl. And if Perl is going to output to the environment, we have to take the characters and output the bytes. On the input side, that's really straightforward. On the input, we can't get any byte above 255 by definition, so that's just going to become character 0 to character 255. No big deal. I wrote out here, I'm pretty sure I got them all the sources of input for a Perl program. None of these can give you any byte that is above 255. So this is really quite a simple problem to solve. Perl does, if you don't like the way that works, if you want to automatically decode your input, you can configure Perl for some of those input channels to automatically decode. So you don't just get a byte to character, a one-to-one correlation. It will actually decode for you so that if you put in, say, curly quotes or whatever, you'll actually get the character code point for curly quotes rather than the 3 code points that correspond to the bytes that you got in. And that's what use UTF-8 does. That's all it does. It takes your source code and applies an auto-decode. It also allows you, if for whatever reason you want to, say, use an accented E in your function name. I've never had a desire to do this, but then again, I grew up speaking English. Maybe somebody who wants to write Perl in Russian really wants to do that. That will let you do that. For those other ways of getting input from the environment or syscalls or $0, there's no format for auto-decoding. Output gets a little dicier because, yeah, it's a lot more interesting. Firstly, because some of our output channels are Unicode aware, some of them are not. For the ones that are, the way it works is if your code point is 0 to 255, 00 to FF, then it will just print out that code point as a byte. So that's why when I had, \XFF, code point 255, that just printed out byte 255. If your code point is above 255, then Perl is going to warn you. It's going to say, I've got a wide character. And what that wide character warning tells you is you forgot to encode. You forgot to convert these character strings to a byte string. And so I'm going to warn you about that. But Perl being Perl, it's still going to try to do something it hopes is useful anyway. And so it's going to UTF-8 encode for you. Why not? UTF-8's a great encoding. And then for our other output channels, file handles, $env, there were actually several holes in the abstraction for $env and up to 536 $0. Those did not print, those didn't, depending on Perl's internal memory, you would actually get a different thing for some of those strings. Those are fixed as of 532 and then 536 for $0. Significantly though, most built-ins though are non-Unicode aware, and regular expressions also by default are non-Unicode aware. So what does that mean? Well, that means under the non-Unicode aware model, there are 3 ranges of code points that are of significance. The first one is 0 to 127 to 7F. Everything that can fit under 7-bit ASCII, you're safe. So a lot of us speaking English, if you're just writing ASCII text, you don't have a problem. And you won't necessarily catch these kinds of things unless you're forcing yourself to work in the range of the second code point range, which is 128 to 255. This is what Perl, and I don't know if it's a standard term or it's just the Perl code, source code, but they call it UTF-8 variant strings. What this is a string that when it's encoded as UTF-8, it differs in its representation from how it would if it were unencoded. Yeah. And then our third range is 256 above. In that range, Perl will actually output the UTF-8 encoded form, but here there's no warning. Because this part of Perl is non-Unicode aware, and so all it's doing is it's taking the internal buffer that Perl scalar stores, it's called the PV if you're up on the Perl's innards, and it's just blitting that PV to the OS without consideration for how the PV actually functions in the Perl programming language. Which means you can have 2 different strings, $A and $B, and $A EQ $B can be true, but if you send those 2 strings to the OS, you'll actually get a different result. And I'm going to demonstrate that a little bit later. Now I've got question marks there kind of to indicate that you can't really reliably know what Perl is going to output. You can, they're just not good ways, and we'll talk more about that later too. If you've read Perl Uni-Toot, this is another one of Perl's Unicode problems. There are so many different documents that offer guidance on all of this, but Perl Uni-Toot has a really useful little diagram. It's the 5-minute Unicode tutorial in there. And it shows just a very simple thing where you take input, you decode it, you process it in Perl, you encode it for output, and then you output your bytes. It's very simple. And if you combine that with what we looked at earlier, all the sources of input and all the sources of output, this is what that would look like. It looks a little complicated, but at least it's consistent. All of your sources of input go through a decode, you process it all, you encode it all, you output it all. This is what use UTF-8 does for you. It introduces an inconsistency into that model. Yeah, and this is why I discourage use of that UTF-8 pragma, because yeah, you remember that your source code is an input, but someone else is going to forget that that string came from source code, or when you tested, you had a constant, but in production, you've read it from a file handle and you've forgotten to decode on your file handle, whatever. It introduces an inconsistency. I do not recommend it. I think it's a little nonsensical. Now, some of you are saying, but I set an auto-encoding on all of my file handles, so it's all nice and neat for me. Well, Perl can set an auto-encode on a lot of parts of it. As far as I can tell, this is the maximum you can set to automatically decode and automatically encode. And as you can tell, it's far from complete. You still have to do all of these encodes and decodes. You still might have forgotten something if you write to $0 or you send something to a system call or you exec. And of course, again, Perl can't tell you when you've forgotten, because to Perl, every string is just an opaque sequence of characters. So to me, it just introduces inconsistency and confusion. I personally prefer just to keep everything simple. And even if that means cluttering things up with a few extra encodes or decodes, I would rather deal with that than have multi kinds of strings and whatever else. Now we're going to talk a little bit about Perl internals. Some of this stuff is kind of the man behind the curtain kind of stuff, but it's at least of interest, if not of practical use. So if you read about Perl and Unicode, you will find things out there that speak as though Perl strings were more complicated than just sequences of characters. We're going to talk a little bit about Perl string storage, and we'll talk more later. For right now, I'm using kind of abstract terminology. Those of you who know some of these answers, know what these actually mean, but for right now, let's just say there are two ways Perl can store your string in memory. There's a light encoding and a heavy encoding. The light one is simple and efficient and fast, but it can only do code points 0 to 255. If you need anything above 255, Perl has to switch to the heavy encoding, which is bigger and slower. Now, the misconception that you usually run into, and that up until about 4 or 5 years ago I actually thought too, is that light strings are byte strings, and then the heavy storage strings are text. That's actually true in some modern programming languages. In Rust, for example, every string is a character string, and it is always stored in UTF-8. So here's something where Perl is actually slightly more efficient than Rust, because if for whatever reason you were to store a byte string as characters in Rust, you would be using UTF-8 for that, which is a heavier storage format than Perl's light storage format. Of course, in Rust, you actually have byte strings. You can store an actual array of U8s, so it's kind of a moot point. But back to Perl, the thing is, you can actually store text stored as light, and you can store bytes as heavy storage. To Perl, again, they're all characters. So these things do happen in production. You can't really assume that one goes the way of the other. This is a truth that really bites anytime you deal with Unicode and Perl. It just kind of is the way it is. The funny thing is, when you read in Perl's documentation, there are parts that talk about those sort of non-Unicode-aware parts of Perl, but they preface it this way: when Unicode does not happen, which is, I don't know if it's kind of a way of disavowing the parts of this that, okay, we know this doesn't actually work yet, we're going to get to it. Anyway, that's the actual title of the section in Perl Unicode. And to illustrate what that means, think a little bit about what this code outputs. Yeah. Well, no surprises here. It just outputs $E. Now think about what this does. It shouldn't, right? In order to understand why that happens, I don't have a slide for this, so my bad. The JSON encode and decode has the effect of turning the $E into heavy storage. And so when Perl outputs that, when Perl gives that resulting heavy string to exec, exec is non-Unicode aware. $E falls into the second range, where it's between 128 and 255. So when you give a string that has one of those code points to exec, the result is actually undefined. And quite a lot of Perl has this problem. There may be more, but I went through all the built-ins and all the operators, and this is what I found, and it's a lot. It's not much production Perl that avoids all of these operators. So the way we normally get around this is to encode the text immediately beforehand, which does work. It does depend on an implementation detail of the encode functions. The encode functions absolutely must output light storage. They all do, as far as I've seen, but nothing actually compels them to do that. It would be correct if they outputted heavy. They just don't, and nobody would use it if they did. The approach I'm going to recommend instead is, of course, to use my module called sysbin mode, which wraps exec. It takes this table of built-ins and wraps basically all of them so that they become Unicode aware. You still have to encode, but we're no longer dependent on the behavior of the encode function. And if you happen to print something that is not bytes compatible, you'll actually get an error. So you get a much saner behavior, and you get something that tells you up front, boom, you did something wrong. So JSON is a common source of frustration for Unicode in Perl. So let's go back to JSON. Now, if you recall, JSON encodes data structures to a blob, not to a string. Okay, we all know how this works. So JSON is bytes of UTF-8. And if there are any JavaScript programmers in here, this is actually of interest. We'll talk later. So JSON encode has two parts then, really. Firstly, you have to take your data structure and you figure out what characters will represent that data structure. And then you're going to take those characters and you encode them as UTF-8. The decode, likewise, is a two-part transform. You take the UTF-8, decode it to characters, and then you take the characters and you figure out your data structure that you're going to give back to the nice Perl application. Ironically enough, JavaScript, the language after which the JSON format is named, doesn't do this. JSON.stringify and JSON.parse are not full JSON encodes and decodes because they don't do the character encoding and decoding. They don't do the UTF-8 step. They only do that first part where I convert my data structure into text. If you actually wanted a full JSON in JavaScript, it would look like this. Now, it doesn't matter though, because JavaScript engines know what's a string and what's a byte array. And so every time a JavaScript engine outputs a string, you always have to define an encoding, right? Any Node.js programmers in here? Yeah, I'm sure some of you are. You're just being a little shy. It's not as simple as just spit it out, right? In Node.js, you either are using some default behavior or you're declaring an encoding or it's reading it from the environment or something like that. Node.js actually does this in a more sane way. But yeah, I just think that's a funny irony that a JSON operation in JavaScript itself is not a full JSON encode. Now Python is interesting because Python's decode and encode, again, Python knows the difference between a text string and a byte string. So Python can actually be smart. If you hand JSON.loads a character string, it knows it already has a character string, so it just grabs the buffer from that. If you hand JSON.loads a byte string, it will UTF-8 decode and then do the rest of the encode. So Python just does the right thing no matter what it's given. Now let's look at JSON and Perl. Take a second, think about what these all do. Well, they sure look like they do the same thing, right? No. As it happens, the longer syntax counterintuitively is not the complete JSON encode. Only the second one, where I have JSON encode JSON, the thing that looks like the shortcut, this is actually the complete one. If you want a full JSON encode with the JSON arrow new thing, you have to explicitly do JSON new arrow UTF-8 parentheses 1 and then encode. And then you will get a full JSON encode. Decode, of course, is the same way. I think this is a common source of UTF-8 and Unicode foibles in Perl, because I think a lot of times when we do these things, we're not necessarily thinking of this little detail. Particularly since so much of our code is written in English, and we just use ASCII for everything, right? Until that one person comes along with an E accent, or they come along with a curly quotes or an emoji or something, and then, well, it worked for me. So, okay, now let's talk about XS modules. Again, sequence of characters is what we're talking about as we define a string. There is a widespread notion that XS authors need to know more about this than the Perl strings, that they need to know the details of how Perl stores the string. Except in rare cases, no. You do not, and you're likely to introduce bugs if you write your XS module with that assumption. This is the ideal of how it should work. The nice C code plays completely inside Perl's C API. And then Perl's C API deals with Perl's internals. So the C code over here doesn't deal with the Perl's internals. And we've got that nice API doing this job of converting between those two models, where Perl's strings are sequences of characters, but C strings are sequences of bytes. Either zero delimited, or you've got some way of tracking how long the byte sequence is. Our ideal tools for doing this in Perl's C API are these sets of macros, where if I've got a string from Perl and I want to get it into C, I either extract it as a byte string or as a UTF-8 string. And if I try to get a byte string from something where the code point exceeds 255, I get a nice happy error. Now, going from C to Perl is a little different. We have macros for doing this. The proper way to get characters from C into Perl is to actually do the decode of UTF-8. This is important because if you don't do this, if you use new SVPVN UTF-8, you are not validating that what you're telling Perl is actual UTF-8 bytes is actually UTF-8 bytes. So you are introducing potential to corrupt Perl. Obviously, it's less performant if you're going to do a full decode. So this is where you have to judge that trade-off. If, for example, your bytes, your C string is coming from like ICU, that's probably valid UTF-8. You can probably trust that. But if you really want to be paranoid, you can decode from, you can vet ICU's input too. The other thing about doing it that way is you're always going to get heavy storage, which if you're doing a lot of regular expression checking, if you have long strings, that can actually make a significant difference. I've seen tests on CPAN, SQLite, when the flag was set when heavy storage was set when it didn't need to be, that made the test take like 30 minutes when it was supposed to take like 30 seconds. It was pretty remarkable. That was under debugging mode too, but just saying. Of course, a lot of us know that there are parts of Perl's C API that basically allow the C code to circumvent those nice interfaces, and you can read directly into the Perl internals. So we get, the sorts of inglory that, happens. For example, for whatever reason, the most visible way in Perl C API to get a C string out of a Perl scalar is called SVPV. Now, if you're new to XS, if you're just wanting, okay, I just want a simple, safe way, just a simple way to get my string out. Okay, SVPV, that looks simple, right? Because it's simple and it's short. It's also the wrong tool because it does the non-Unicode-Aware operation of grabbing Perl's internal representation of that string and just giving it to C. So we're going to have the situation where I've got $A EQ $B where that's true, but C will actually receive two different strings, two different byte buffers for those two scalars. And then if you directly manipulate, I guess I got premature with myself, the UTF-8 flag, if you directly manipulate that through the API, you have potential to corrupt Perl. And you generally don't want to do that. So please avoid the make lemonade from lemons and use the nice parts of the Perl API that do not depend on Perl's internals. There is a case where SVPV is useful, and that is if you are writing very performance-sensitive code. I did see a module recently where somebody was tight looping around large strings, and yes, if you're doing that, then as an optimization, it makes sense to look at the string's internal storage. But for the garden variety of case where you're just, writing a binding to a C library or something, no, you're much better off playing behind the abstraction. Don't worry about Perl's internals, even in your XS code. A really important part of all of this is documentation and how we name things. This is where Mojolicious, I think, ++. Mojo does an excellent job, I think, of being very careful about labeling all of its points of input or output as this expects bytes. This expects characters, this gives bytes or characters. So when I've used Mojolicious for that end, I noted that and I was very happy to see that. I also think it's just good when you make a CPAN module, make a heading in your module that just describes how you're approaching character encoding. One of my modules, for example, is an embedding of Quick.js. It's a JavaScript engine, so of course all of the strings in and out should be character strings. And so I made a note of that like up front, like right after the description, character encoding. And so hopefully that's a conspicuous enough heads up to anyone using this, okay, that's what I need to do in order to call in this module and have things work as I expect them to. Even if you're not writing APIs though, even just for your $foo or whatever, if you're actually combining byte strings and character strings, please name them somehow. Suffix them _B _U or whatever. Do some indicator to the next maintainer of your code what this is, because Perl absolutely cannot tell you, and it won't bite you until it does. And here's another fun one. UTF-8 String. To understand why this term is problematic and maybe even controversial, we have to look at parts of Perl's internals even more. Now, for most of us, for audiences 1 and 2, in my little perspectives thing at the beginning of the speech, this is what a UTF-8 string is. It is a string whose code points represent the UTF-8 encoding of some Unicode characters, right? And again, before I go on, again, remember, neither Perl applications nor most C API callers need to know what I'm about to show you. This is mostly informational. Yeah. So, as it happens, light storage is in fact basically just Latin 1. 1 byte per character. Heavy storage is not quite UTF-8. It's what I've seen more recently called generalized UTF-8, which basically just means it can store certain code points that the UTF-8 standard forbids. For most intents and purposes, though, it is just UTF-8. So if you want to look at, if you're looking at Perl's internals, this is kind of a standard tool for how to dissect a scalar and see what exactly is inside it, how Perl's internals represent it. To a Perl maintainer, that flag, that UTF-8 over there, that's what makes something UTF-8. Now, notice a certain contradiction here. This is what the non-Jedi masters call a UTF-8 string, something that was the output of a UTF-8 encode. This is what a Jedi master thinks of as a UTF-8 string, the output of a UTF-8 decode. A Jedi master looks at this, however, and says, that's not a UTF-8 string because it's not flagged as UTF-8. And then you can get scenarios where both the Jedi master and the non-Jedi agree, okay, yep, that's a UTF-8 string, because you can actually have scalars that have that flag set, but that are also the output of a UTF-8 encode. And as I showed you with the JSON round-tripping example earlier, it's not that esoteric of a case. I propose to any Perl maintainers who may be aware of this talk, let's think about this term instead. When we're talking about Perl's internals, let's try to be careful and use this term to disambiguate things. If you're talking specifically about Perl's internals, please say flags. UTF-8 flagged string. I think that will actually clear up a surprising amount of the discussion. Because where I found the most confusion is when I talk to people who are competent on both ends of the topic. So if you look in the UTF-8 module, there are 4 operations that may stick out to you. Obviously, decode and encode, those are of practical use. Upgrade and downgrade may be a little less clear what those are for. Those are for changing light to heavy or heavy to light. And so UTF-8 upgrade is not useful in production as far as I can tell. What it is useful for is testing. If you want to find, for example, XS modules that might have the bugs, that SVPV and stuff like that, the non-Unicode-Aware stuff, you want to find that stuff, test with UTF-8 upgrade. Because that will take your string and upgrade it to Perl's heavy storage. Then if you give it to something that you think might be misbehaving under that scenario, that's how you can catch that. UTF-8 downgrade is what you do when you have an XS module whose maintainer, for reasons of backward compatibility, can't fix the problem. This, for example, is the case with netcurl. Widely used module, I think it's great, but it has this XS problem. And so I wrote a little wrapper around netcurl, and one of the things I did with it was I made it always SV downgrade. And so no more UTF-8 problem. This kind of sums up, though, the real confusion of the term. The difference between what a Perl user calls a UTF-8 string versus what a Perl maintainer calls a UTF-8 string. And as you can see, they're almost mirror images of each other. It's kind of funny. I think with the alternate wording, it gets a little bit clearer. Then there's this function. What do we think this does? Well, gosh, it should tell me if a string is a UTF-8 string, right? Well, sure. Again, if you're a Perl maintainer. It sure looks like it ought to be a UTF-8 validator, though. And unfortunately, there are an awful lot more of us who are just kind of mortal Perl users. So I would love to see this renamed with an alias for backward compatibility to something like this, so that it looks a little more esoteric and You're encouraged more to look at the documentation to make sure, does this do what I think it does? So anyway, I've given you a bunch of fixes and recommendations along the way, but this is kind of a standard list of everything that I would say things should use in order to be clear of UTF-8 and Unicode problems. Firstly, always use the Unicode strings feature, always use Unicode eval and eval bytes. These avoid some of those when Unicode doesn't happen problems. Use 536. I think that actually includes those other features. Gosh, I wish I'd thought of that when I made the slide. Use sysbin mode. If you can find any context where it should not be used, I would very much love to know. As far as I can tell, absolutely everywhere, even on Windows, sysbin mode should be used, at least for now. XS modules, just be very, very careful which ones have this bug. Always test them, UTF-8 upgrade, downgrade. You may have to downgrade before you give strings to the XS module. Longer term, Perl really needs to learn how to do this because it really hurts that we can't. If Perl can be taught to reliably differentiate text strings from byte strings, we could even do this, where if the path is text, we can encode as per the environment. We could even on Windows use Unicode APIs, which would actually make Perl a heck of a lot more palatable for use on Windows. If you haven't tried it, Perl on Windows is really hard if you have Unicode in your path names. And then of course, if the path is binary, you just react again accordingly. You get even error on Windows, since on Windows, paths are not binary at all. 20 years ago, Perl was a great tool for text processing. It's still good today, but in 2022, I think Unicode is just too important. And all these liabilities I've talked about, I think it seriously undermines the claim that Perl is now a good tool for text processing. You know, those of us who want to see this language, continue to flourish and maybe even regain some of its erstwhile acclaim and renown, we really need to fix this, I think. And on that happy note, thanks. I'm like right at time box, but are there any questions? It allows that, but it also does an auto-decode on any string literals in the code. So if you write my foo equals quote, E with an accent, you're going to get a different string than you would have if you left off use UTF-8. You'll have different code points. Correct. Yeah. And I should have prefaced that. I'm assuming everybody uses a UTF-8 editor. I know that's not a safe assumption, but I guess if you want to use big 1252 or whatever, big 5. Yeah, Dave. I believe that's basically the CSDA thing, right? Where it does everything possible. It still doesn't get everything. So yeah, I think I think it should be UTF-8 most. But yeah, I'm sure it's a wonderful module. If it can't do absolutely everything, it shouldn't be called all. Okay, thanks.